right, geometry. This is going to complete chapter 9. This is chapter 9, section 7, law of sines and cosines. We're going to do 3 examples today. We're going to do using sine and cosine to find the area of a triangle that's not a right triangle, and we won't have to draw an altitude. And we're also going to find some missing pieces using law of sines and cosines. And again, this section is for triangles that are not right triangles. So everything up to this point in chapter 9 has been for right triangles only, but these are not. Okay, so let's go ahead and take a look at the area of a triangle. And again, in this case, it kind of just depends on what they give you. We'll see that in just a second. So the first one is going to be 1/2 BC sine A. Remember that capital letters are the angles and the lowercase letters are the sines. The second one is going to be 1/2 AC sine of B. And you can probably see where we're going with the next one. The next one is going to be 1/2 of AB sine of C. And so let's get an example. This is going to be example 2 on page 458 if you want to follow along there. And so I'm going to draw that real quick and I'll be right back with you. Okay, so here's our example, and because we were given A, we are going to do area equals 1/2 BC sine A. Remember that side B and side C, those are the sides that are opposite the specific angles. So the side that's opposite angle B is going to be 17. The side that's opposite angle C is going to be 19. So this is going to look like this. Area is 1/2. Side B is 17. Side C is 19. And then sine of 135 degrees. Let me grab a calculator real quick. Since it's all multiplication, I can enter it in any way. What I'm going to do first, just it's simpler for me, is I'm going to find out what the sine of 135 is. That way I don't have to round. And I pull up that value as 0.7071, continuing. Then I'm going to multiply that times 19. Then I'm going to multiply that times 17. And then I'm going to divide that by 2. You could multiply it by 1/2 or 0.5. Either way, it doesn't matter. And that's going to come out to approximately, if I'm rounded to the nearest tenth, which is probably what they're going to do on most of them, is 114.2. It's 114.19. We just bump that up to 0.2. So again, it will give you a specification of what to round it to. So in this case, that's going to be its area. So that's going to be units squared. And I do want you to put the units on there. If they don't give them, again, just signify them as units. So that takes care of area. Let's move on to the law of sines. Again, remember we're going to use the law of sines in triangles that are not right, and the law of sines uses a proportion, and what it says is it compares the sides to the angles. So the sine of angle A over side A equals sine of B over side B equals sine of C over side C. Now, when we set these up, we won't be comparing 3 things. We'll only use 2 of the sides or 2 of the angles. It just depends on what they give us. So I'm going to go ahead and set up example number 3 that's on page 459. and we will get to that in just a moment. In this example, my goal is to find angle B, so I've labeled everything except the two angles, obviously, because we can't find those as of yet, but we're going to find angle B here in just a minute. I know that I have everything for A. I have angle A, and I have side A. Okay, so that's going to be the sine of 115 all over 20. Now, I know I'm trying to find angle B, so that's going to be my unknown. But I do know side B, which is 11. So this is the proportion that I'm going to set up. And now we're going to use all of our calculator magic and get an answer here. And so I'm going to find the sine of 115 degrees. So sine button 115. That gives me 0.9063 repeating. Not repeating, but it goes on. It's extended. I'm going to go ahead and multiply that times 11. And that's going to give me 9.9693. You can see where I'm going with this. And so I am actually going to put all of those digits because I want it to be very accurate. Again, I'm showing you the long way. There's some calculator work that you can make this a lot easier. And then when I cross multiply that, that's going to be 20 sine B. So I left that in my calculator. I'm going to divide both sides by 20. Okay, so I've got my decimal value equals sine of B. So what I'm going to do now, if you remember back when we found actual angle values, let me extend that page just a little bit so I don't have to reach down there. When I find actual angle values, I need to use my sine of -1 function. So you're going to hit second and hit your sine button. And then for those of you who have a Texas Instruments calculator, you're going to hit second and your negative button, which is going to give you your answer. And once you hit equals, that's going to be approximately 29. If we did that to the nearest tenth, that's going to be 29.9 degrees. So B is actually 29.9 degrees. And we'll talk about calculator work on that when we get there in class. So now let's look at the law of cosines. We're going to be given a little bit different information. And so for the law of cosines, I'm going to go over and do example number 6 on page 461. So I'm going to get that ready real quick, and I'll be right back with you. Okay, I forgot before we do that, I want to go ahead and identify the formula for the law of cosines. And it looks like this. Again, there are 3 of them, kind of going back to the area problem where there were 3 different ones just depending on what you were given. And also the law of sines, there were 3 ratios depending on what you were given. So the first one is going to be a squared equals b squared plus c squared minus 2bc cosine of a. Okay, a squared equals b squared plus c squared minus 2bc cosine of a. Notice that if I have a squared on the left hand side, I'm finding the cosine of angle A. And so we're going to go to the second one. Again, you can probably see what's going to happen here. Our second choice would be b squared equals a squared plus c squared minus 2ac cosine of b. Get out of there. And then our last one is c squared equals a squared plus b squared minus 2ab cosine of c.